Hey guys, as promised, this is the video for the second part of the notes. It's the graphing logs part of the notes. So what's interesting about graphing a log is usually when we're going to use an XY table like always, but usually what we do is we put X as the input. So these are usually in the X column. But you'll see why. If I write this as in exponential form, you're going to see why it makes more sense to plug in Y values. So let's write in exponential form. So if you remember, this is the base, the 5. The Y is the exponent, and the result is on this side. So see how it makes sense here. If I have 5 to the Y equals X, it makes sense to plug in the Y values. So if I plug in Y is -1, I get 5 to the -1 for X, and 5 to the -1 is 1/5. If I make Y 0, I get 5 to the 0 power, which we know is 1. Anything to the 0 is 1. Here, if I make Y1, I get 5 to the 1st. And here, if I make Y2, I get 5 squared. So let's see what a log looks like when I graph it. So I'm going to have 1/5, comma, -1, 1, comma, 0, 5, comma, 1, and 25, comma, 2. So if you notice here, guys, oh, that is not a good, sorry, my hand doesn't make it easy for me to graph these things. So if you notice, imagine flipping this on its side, right? It's like it's like one of our exponential functions, except it's the inverse of it, right? So notice with the exponential functions, they get really, really close. If you remember those swoops, they get very, very close to 0, right, on the X. Now we're getting very, very close to 0 on the Y. So this is a basic shape of a log function. So we're going to try another one of these, and we'll do the same exact thing. So I'm going to erase, since I only have one board at home here. Sorry, this is going to take a little longer. I'm going to use the same Y values, right? So I'll use the same Y values, and this time I'm going to plug in to this log base 1/3 equation. Okay, so again, what we want to do is we want to write it in exponential form. So to write it in exponential form, I know that the 1/3 is the base, and I'm going to use the parentheses because that's a fraction. So 1/3 to the Y equals X. Right? So again, it makes sense for us to plug in Y values. So if I make Y -1, 1/3 to the -1 is 3, right? Because that means flip it over. 1/3 to the 0 is 1. 1/3 to the 1st is 1/3. And 1/3 to the 2nd is 1/9. So remember, when our base was not a number, wasn't a fraction like 1/3, our graph looked like this. So let's see what's going to happen here. See how it's going to be different now that we have a fraction that's below 1. Notice we're going to have that same swoopy shape. Oh, sorry guys. Only this time it's going to be upside down, right? So it's going to be getting really close to this x-axis, but the other way. So the fact that it's a fraction less than 1 means instead of swooping this way, it's going to swoop this way. Okay, one other thing I want to do. I want to see what happened. Let's go back to the log base 5. And this time, we're going to find the inverse. And we're going to see, okay, well, what happens if I find the inverse and then I plug in the x values that I did here for the y values? So let's find the inverse. So I'm going to find, we've got log base 5x, and we're going to find the inverse. And just to remind you, the table for log base 5x, I'm going to write it back up here, looked like this. It was -1, 0, 1, 2. This was 1/5. This was 1. This was 5. And this was 25. So remember to find the inverse. What we're going to do is we're going to switch x and y. So here's my equation. It's going to say x equals log base 5 of y. Now we're going to write it in exponent form, like we did in the previous video. If I write it in exponent form, there's my base, there's my exponent, and the y is on this side. So let's plug in the x's, -1, 0, 1, and 2. So 5 to the negative first gives me 1/5. Make x 0, 5 to the 0 equals 1. 5 to the first equals 5. And 5 to the second equals 25. So guys, what do you notice about these? What do we know about inverses? Remember when we were graphing them? We know that we can take any inverse and just switch the x and y's. Right? And that's how we know here that we've got ourselves inverses. Right? So that's going to be the relationship between x and y when they're inverses of each other. Okay, guys, that's it. I will see you later.